Hey friends, welcome back to Civil Engineering Mastery. In this video, we are going to discuss about how do we transfer the slab load to the column. As we all know that load transfer is very important in all the structure. If you take any structure, the load transfer is very important because according to the load only we are going to design the structural member. So if we design the structural members properly, then the structure will be durable during its intended lifetime. In this video, first let's calculate all the loads manually, how we can transfer the slab load to the column, and then let's do the same calculation using Etabs software, and finally we can compare both the result, manual calculation as well as Etabs results. So without further delay, let's begin now. Let's start off with dead load. Under dead load we have self weight, floor finish, sunk load, waterproof load, and then we have live load. Let's see how we can calculate the self weight. Self weight is the dead weight of all the structural member. So for slab, if you take the slab thickness is 5 inches, then you have to calculate the self weight of the slab by using the thickness and unit weight of RCC. 5 inches is 125 mm and unit weight of RCC is 25. So if we multiply this, you get 3.125 kilonewton per meter square as the self weight of the slab. Next one is floor finish load. Let's consider 3-inch thickness of the floor finish as 3 inches, and here I have considered the unit weight of the floor finish material as 20 kilonewton per meter cube. So if we multiply this, we get 1.5 kilonewton per meter square as the floor finish load. Next, let's look into the sunk load. Sunken thickness is 10 inches. So if you take the slab, wherever you have bathroom slab or utility area, balcony, so in that areas we provide sunk slab. That means the slab will be sunken by some thickness from the actual level of the floor. So this sunk is used to provide the pipe, to lay the pipelines inside this, and then after that we need to use some filling material to fill this. Here we are using the material as cinder. Unit weight of cinder is 8 kilonewton per meter cube. For unit weight of materials, you have to refer IS 875 part 1 code. So sunk thickness is 10 inches, that is 250 mm, 0.25 meter multiplied by 8 is the unit weight. So we get the sunk load as 2 kilonewton per meter square. You can see the sunk slab here. This is the bathroom floor, actual floor level, and your slab is sunken by some distance, say 10 inches, and in between pipelines are running like this. On top of it we have to fill some material. Next one is waterproofing load. This varies according to the waterproofing material which we use on the roof slab. This will come on the roof slab, top of the roof. Generally we consider 1 to 2 kilonewton per meter square as the waterproof load on roof slab. Next one is live load. As per IS 875 part 2, for residential we need to consider 2 kilonewton per meter square. Now we know how do we calculate the slab load. That means like dead weight of the slab, floor finish load, and other loads which are coming on the slab. Now let's take one slab. For example, 2.5 meter by 3.5 meter slab. It is a two-way slab. We need to find out whether it is a two-way slab or one-way slab by using Ly by Lx ratio. If Ly by Lx ratio is less than 2, then it is a two-way slab. If it is more than 2, then it is a one-way slab. So here let's consider this two-way slab, and then let's look into the load distribution. How we can transfer the two-way slab load to the beams, and then from the beams to the columns. As per IS 456-2000, we have the load distribution mechanism for two-way slab. If you look into this figure, the two-way slab load need to be transferred according to this, like trapezoidal area and triangular area, and the angle of the distribution is at 45 degrees. So if you consider the slab like this, you have beam 1 and beam 2. Similarly, this is also beam 1 and this is beam 2. So this trapezoidal area of the load will be transferring to beam 1, and this triangular area of the load will be transferring to this beam 2. So this is the load transfer mechanism. We can even call this as a yield line theory. Now let's look into the load calculation. First we need to find out the self weight of the slab, that is 3.125 kilonewton per meter square. As we have discussed before, the thickness of the slab is 125 mm and floor finish is 1.5 kilonewton per meter square. Sunk load is 2 kilonewton per meter square and live load is 2 kilonewton per meter square. So if we add this all together, we get 8.625 kilonewton per meter square as the total load which is coming on the slab. Now let's calculate the load which is coming on B1, because our goal is to find out the load which is coming on the column. Let's consider this column as C1. So we are going to find out the load on this column. So for that we need to transfer the slab load to the beam and then beam load to this column. So particularly this column will carry half of this beam load and half of this beam load. So let's find out the load coming on B1 and B2 and then let's calculate the load which is coming on this column. Find out the load on B1. We need to consider the shorter span as 2.5 meter. Total load on slab is 8.625 kilonewton per meter square. So we need to consider the trapezoidal load distribution. So this trapezoidal area of the load will transfer to this beam 1. So to calculate that, we have this formula WLX upon 2 multiplied by 1 minus 1 upon 3 k square. So here k represents Ly by Lx. Ly by Lx is the ratio between longer span to the shorter span. W is the load on the slab and then Lx is the shorter span, which is 2.5. So if we calculate this, we get the load on B1 as 8.94 kilonewton per meter. So this is the uniformly distributed load which is acting on this beam 1. Next, let's calculate the load on B2. Total load on slab, we know we need to consider the triangular load distribution over here. We need to consider triangular load distribution. So to calculate this triangular load distribution, the formula is WLX upon 3. Here the total load of the slab is W and then Lx is 2.5 meter upon 3. So if we calculate this, we get 7.188 kilonewton per meter. So this is the load on B2. Now we know the load on B1 and load on B2. Now we need to find out the load which is coming on this column. So slab load on B1 is 8.94 kilonewton per meter. So that will act on this beam. In addition to that slab load, we need to calculate the self weight of the beam, that is dead weight of the beam. Beam size is 300 by 400. So 0.3 multiplied by 0.4, the dimension of the beam multiplied by unit weight of RCC, we get 3 kilonewton per meter. So this load also we need to add in addition to this load B1. So slab load plus self weight of the beam together will act on this beam. Okay, so that is 11.94 kilonewton per meter. If we consider this beam, so this is beam 1, span is 3.5 meter, UDL is acting on it. So load multiplied by distance upon 2, so that we'll get the load on this column in kilonewton. So if we solve this, we get 20.89 kilonewton which is coming on column C1 from beam 1. So in addition to this load, this column C1 will carry half of the load from B2. That also we need to calculate. We have calculated before slab load on B2, that is 7.188 kilonewton per meter, and self weight of the beam, we know that dimension multiplied by unit weight of RCC. We need to add these two together and then apply it as a UDL. Here the span is 2.5 meter. So load multiplied by 2.5 upon 2, we get the load on this column. So half of beam 2 load will be coming to this column C1, that is 12.735 kilonewton. Now let's calculate the total load. Load from B1 is 20.89, load from B2 is 12.735 kilonewton. So which is transferring to this column C1, and in addition to this we need to find out the dead weight of the column, that is self weight of the column. So column size is 300 by 300, so 0.3 multiplied by 0.3, and height of the column, the floor height we need to consider, that is 3 meter multiplied by unit weight of RCC, so that comes around 6.75 kilonewton. So if we add all these three loads, the total load which is coming on column C1 is 40.37 kilonewton. So this is as per the manual calculation. Now let's apply the same load on Etabs software and then see how much load we are getting on column C1. Now let's open Etabs software and then start modeling the structure. Select metric unit, steel section database is Indian, design code IS 800, concrete design code is IS 456-2000, give OK. And here select grid only option and then give OK. You can go to edit and then modify the edit story and grid system. Under grid system, select modify and show grid system. So here we can give this one as 3.5 and this we don't want, just delete it. And similarly here we can give this as 2.5 and these two we don't want, sorry, delete 3 and 4 because we have only two grids, 1 and 2, and this side it is A and B. Give OK. Story also we can delete it. Go to modify and then right click on this, delete story, and again story 3 also we can delete, and again this one also we can delete. Give OK. Now we have got the structure. Let's define the material properties. Go to add new material, select India, material type as concrete, standard Indian, select the grade as M25 and then give OK. M25 has been added, and again add one more thing for rebar, India, concrete, material type as rebar, and then grade we can choose HYSD grade 415, give OK and give OK. Next go to section properties, frame section, add new property, concrete rectangular. Let's add the properties, column 300 by 300, column size is 300 by 300, and select the material as M25. Here give the size as 300 by 300, and then reinforcement we can modify here. This is for column, longitudinal bars and confinement bars is HYSD 415, rectangular column cover is 40 mm. This and all let's keep it as default one. Give OK. Again add new property, concrete rectangular, select this one, and now let's add beam 300 by 400. Beam size is 300 by 400 mm. Now select grade of concrete, depth as 400 and width as 300, beam size. Now let's change this one as beam option, and here select HOSD bar, and for clear cover is 25 mm for beams. Give OK, again OK. Next define section property, slab section. Let's add a new property as S125, slab thickness is 125 mm, M25. Let's select shell thin and then here slab thickness is 125 mm. Give OK. Now we have to assign the property. So go to this draw menu bar, quick draw menu bar, and here let's select this one. This is for columns. Here we have to select the property as column 300 by 300. So next we can draw the beams. Next let's draw the slab. Just draw a rectangular floor and then let's select this one, drag like this. We have drawn the slab. Next we need to define the load. Go to load pattern. Under dead load we need to keep the self weight multiplier as 1, and then we need to add the floor finish load type as super dead load. Add a new load, and then sunk load we need to add. That also comes under super dead load only. And then live load is already added. Give OK. Let's define load combination too. Combination is, let's select dead load plus live load only. Add floor finish, sunk load and live load. All the factors are one scale factor. Give OK. Go to assign, select shell load, uniform. Under this one, floor finish, that is 1.5 kilonewton per meter square. Apply OK. So you have to select the shell and then give apply OK. That is assigned. Again go to shell load, uniform, select this one. Under sunk load it is 2 kilonewton per meter square, and select this one. Go to assign. Under shell load select uniform, floor finish is 1.5 kilonewton per meter square, and again select this one. Go to shell load, uniform, and then select sunk load 2 kilonewton per meter square. So this is add to existing load because already we have added the floor finish load, and give apply OK. Next, select this one, go to assign, shell load, uniform, select live load. This also add to existing load, because already we have added sunk load, floor finish load, and then now we have added the live load. That's all. Rest other dead weight and all etabs calculate automatically. That's all about the load assignments. Now let's go to analysis. Click on check model, select all, give OK. There is no warning, and before doing the analysis we need to add the support. Go to this base view, select these nodes, and then go to assign, joint, restraint. So here we have to select pixel 1, apply, OK. So we have done all the load assignments, support and properties. Next, let's do the analysis. Now go to display force and stress diagram. Here select support reactions, select combo dead load plus live load, apply, OK. See, we have got the support reactions. If you look into this one, we have got 33.71, almost 34 kilonewton as the total load on this column. So as per our manual calculation, we have got the 40 kilonewton as the load on this column, and as per etabs we have got the load as 33.71, that is around 34 kilonewton. So this is how we have to transfer the slab load to the columns. There is little variation between manual calculation and the software. So this is how we need to do the load transfer from slab to column. So friends, I hope you all like this video. If you want to compare the same with the StatPro software, please do let me know in the comment box. Your comments are always welcome, and don't forget to subscribe this channel for more videos. Thank you for watching.